Okay, well, welcome to Notes 12.3, Horizontal Compressions. What we want to do today is to examine and learn about horizontal compressions and what they are in terms of functions. And so first of all, let's look up here where we have our text boxes. Vertical dilation is what we'll look at first, and then we'll go with horizontal dilation. A vertical dilation, you have two things. You have a vertical stretch, you have a vertical compression. Okay, so if you stretch this, this function vertically, you're going to multiply by k on the outside of the parentheses, and that's if k is bigger than 1. Okay, now if you multiply by k outside of the parentheses and k is between 0 and 1, that will be a vertical compression. Okay, so it will squish it down. All right, now let's look over at horizontal dilation. I need you to fill these in. Horizontal stretch is going to go side to side, and as we've learned, if you multiply by k inside of the parentheses, that's going to be a side-to-side movement, side-to-side dilation. If k is greater than 1, that would be a stretch, and if k is between 0 and 1, it will be a compression, so it will squish it down. So let's look at number 1 right here. It says consider the graph of f of x below. And then it says to graph two things. On the left, we're going to graph g of x. We're going to multiply the function by 2. And then on the right, we'll multiply by 0.5. That would be h of x. And then we'll describe each transformation. So I have set up a table here, and I need you to do the same. So take a second, pause the video if you need to, and set up x. We're going to choose these x values based on the function that's already graphed for us, and you can look for the x values. They look like exact x values here, so that's where these came from. Nothing special about them except for the fact that this function has those x values. And then first what we'll do is we'll give our y values for each of those x values. So if you look at the graph, you've got when x is negative 3, you're looking at a y value of 3. When x is negative 2, you have a y value of 2. When x is negative 1, you're back up at 3. 0, you're at 1. Now we have a 1/2, and that's going to be 0. And look at 2, negative 4. And 3, we skipped 3. 4, we have a 0. Okay. Now let's take this and let's multiply each of the f of x values by 2. And so for the g of x function, we would have a value of 6. We would have a value, we would have a value of 4. We would have a value of 6. We would have a value of 2, 0, negative 8, and 0. So now what we'll do is plot these values, negative 3, comma 6. So left 3, up 6. There's a dot. Or a point, negative 2, 4, so negative 2, comma 4, negative 1, comma 6, and you'll see that this will be somewhat of a curve here, okay, but it's a vertical stretch. And then you have 0, comma 2, you have a 1/2, comma 0, you have 2, comma negative 8, negative 5, 6, 7, and this will be slightly off the graph. Sorry about that. And then you will have 4, comma 0 right here. And so let's connect these ordered pairs with a straight line here. And I'm a little bit off because of my ordered pair down there. And so let's label what we have here on our graph. So this is going to be g of x. And over here, we had started with f of x. And we are supposed to describe the function, or the transformation. This would be a vertical stretch with a scale factor of 2, because 2 is what we multiply. So let's look at number 1b, I guess you could say. Let's look at the same function, but we're going to multiply by 0.5. So this is where we'll do h of x. And so what I've chosen here are the x values of negative 3, negative 2, negative 1, 0. I skipped over the 0.5 this time because when I multiply by 0.5, that's going to become something that's really small to work with there. So we'll skip over that. We'll go with 2 and 4. So that's what I have as my x values. Take a second to make this table. Pause the video if you need to. And now what I'm going to do is I'm going to get the y values. Negative 3 is, again, it's 3. And negative 2 is at negative 2. Negative 1 is up at 3. And then we're looking at 0, 1, 2, negative 4, and 4, 0. Okay, now what I'm going to do is let's find the y values for h of x. And so at negative 3, what we're going to do is we're going to multiply 0.5 by 3, and we'll get 1.5. Multiply 0.5 by negative 2, and you'll get negative 1. 0.5 times 3, 1.5. 0.5 times 1 is 0.5. We'll get a negative 2 here and a 0 here. Now I have ordered pairs of negative 3 comma 1.5. So negative 3 and then 1.5 right here. Negative 2 and negative 1. Let's see, negative 1 and 1.5. 0 and 0.5. 2, negative 2. And 4, 0. And it looks like I've got a little error here with my negative 1. I'm going to make sure that that's a positive 1. Sorry about that. It's going to change my ordered pair over here. So that would be negative 2 comma 1. There we go. Now what I'll do is connect with a smooth curve and do the best that you can here with your pencil, and you should have a vertically compressed version of the original function f of x. Now what we need to do is we need to give a description of the transformation, and it looks like there's a vertical compression with a scale factor of 0.5. Again, that was what we multiplied outside of the parentheses. That's how I know what my scale factor is. Okay, at number 2, things are going to change slightly. Think of number 1. In terms of number 1, we multiplied the y values by the scale factor because it was going to be a vertical change, a vertical dilation. Now, in number 2, it's going to be a horizontal change, a horizontal dilation. And so because we're going to have a side-to-side movement that changes, we need to multiply the x values by the scale factor, okay? And so what I need you to do at this point, pause the video, insert this table right here, but leave a column for the new x values, okay? The y values are going to stay the same because it's going to stretch side to side, so y values don't move. Copy that table. Okay, so think about the graph of a of x. We are going to create that. What we have is f of x, actually f of 2x. Okay, f of 2x is going to produce a scale factor of 1/2. Now this is the reciprocal. Okay, this is the difference here on this example. This is the reciprocal. That's what our scale factor is going to be. Okay, it would be so much easier if we just multiply by a number here. We're going to multiply by the reciprocal. Okay, so the half, we're going to right here multiply by 1/2. All right, so this is going to be a negative 1.5, and that would be negative 1.5 comma 3. So negative 1.5 comma 3. And then right here, this is going to be negative 1, so we're at negative 2 comma, negative 1 comma 2. Okay, and this is going to be negative 0.5, so that's at negative 0.5 comma 3. This is going to be at 0 still. This is going to be at 0.25. Right, so that's going to be 0.25 comma 0. Right. And let me just make a little change here. That is supposed to be at 0 comma 1. Sorry about that, 0 comma 1. Then 0.25 comma 0. And now we are at 1, so this is 1, negative 4. So 1, negative 4. And this is going to be at 2, so it's 2 comma 0. So back up here. All right, now try your best to connect the dots. Okay, and then we're going to be doing vertical curve down, a vertical line down there, and there is your side-to-side compression, your horizontal compression. And what we need to do now is we need to describe the transformation. So this is going to be a horizontal compression with a scale factor of 1/2. And remember, that comes from the reciprocal of what was inside of the parentheses. So your horizontal compression is going to be different than how we did the vertical. Okay, let's look at the second example. So this is part 2 of this example. We're going to create b of x. And again, pause the video. I want you to create a table that I've got right here. Leave this middle column open for the new x values. And again, that's because we have a horizontal change. And so the x values are going to create the movement. So we're going to come up with new x values. In order to do that, we have, let's see, f of 0.5x. That is going to give us a scale factor of 1 over 0.5. That's the reciprocal, right? 0.5 over 1, flip it, 1 over 0.5, which is going to give us k equals 2. And so now let's come up with our new x values. -6, -4, -2, 0, 1, 1/2 times 2, 1, 4, and 8. Okay, these are the new ordered pairs, -6, comma 3. -6, comma 3 is here. -4, comma 2. -2, comma 3. As you can see, it's taking this kind of bowl shape and really stretching it out horizontally. 0, comma 1. Now we're coming up with this stretched out version of the diagonal. 1, comma 0. 4, comma -4. And 8, comma 0, which would be approximately right there. Now what we need to do is connect our dots as best we can. And as you can see, it's taken the red function, f of x, and it has stretched it out horizontally by a scale factor of 2. So let's go through and actually label these. This should be b of x. I forgot to do that on the previous graph. And again, here's f of x in red. Over here, the red is f of x, and the orange was a of x. And to finish this question, let's describe this is a horizontal stretch with a scale factor of 2. And again, the 2 resulted from the reciprocal of what was inside the parentheses. Now looking at number 3, it says graph the following functions using their parent functions and your knowledge of vertical and horizontal stretches and compressions. So in this case, first of all, this must have a parent function of 2 to the x. So parent function, it wouldn't be g of x, it's going to be something else, a different letter. So f of x, 2 to the x. Now, what I need you to do is pause the video, go through and copy in this table. -2 through 2 is just something that I chose. I tend to choose those values quite a bit, and I like to choose things right around 0, 0 because sometimes interesting things happen at 0, 0. Now, you might wonder where we got these values in red. These y values would be resulting from the parent function, okay? The parent function of 2 to the x. So if you put 2 to the -2, it becomes 1/4, 2 to the -1, 1/2, 2 to the 0, 1, and so that's where those are coming from. So now let's graph this parent function, -2, comma 1/4, -1, comma 1/2, sorry, right there, 0, comma 1, 1, comma 2, and 2, comma 4. Connect with a smooth curve. And this is going to be f of x. Now, looking at the location of the 3, it would be considered inside of the parentheses. That means this is going to be a horizontal movement. And because we have 3, to find the scale factor, take its reciprocal. Reciprocal of 3 is 1/3. Therefore, we have a horizontal compression with a scale factor of 1/3. How do I know it's a compression? If you go back to this first part of the note, if k is between 0 and 1, it is a compression. Since it is a horizontal compression, scale factor of 3, the x value is going to be the one that is affected. So compress x by 1/3. All right, so that is going to be this column here, the new x values. We'll keep the y values. 1/3 of -2 is -2/3. We have -1/3. We have 0. We have 1/3. And we have 2/3. We are finally ready to graph g of x. We have the -2/3, 1/4. So -2/3, 1/4. Kind of hard to put that on the graph, but -1/3, 1/2. 0, 1. 1/3, 2. And 2/3, 4. And as best you can, connect with a smooth curve. And let's label this g of x. So as you can see, the original f of x function has been compressed from both sides. Scale factor of 1/3, and there is our new function. So let's look at number 4. We have g of x equals 3 times 2 to the x power. What we need to notice here is, first of all, the parent function has to be 2 to the x. All right, we'll call this f of x equals 2 to the x. So I have my x values here. I am going to have you fill the table in as is right now. The 3 is outside of the parentheses. This is going to be a vertical change. Therefore, I'm going to come up with new y values. New y values. Okay, so here are my x values. Here are the y values of the parent function. I'm going to leave this column open now for the new y values because it'll be a vertical change. Okay, so how do I get these original y values from the parent function? It's 2 to the -2 power, 2 to the -1 power, 2 to the 0 power 1, 2 to the 2 to the 1 power 2, 2 to the 2 is 4. All right, so that's where those are coming from. If you haven't paused the video to fill in this table, do so now. What I'm going to do is I'm going to plot these points. So at -2, 1/4, -1, 1/2, 0, 1, and 1, 2, and 2, 4. And as before, connect those with a smooth curve. That is f of x. Now, I'm expecting a vertical change here, okay? And so we're going to come up with new y values. So the resulting function, g, is going to simply multiply the y values by 3. So we should have 3/4, 3/2, 3, 6, and 12. And again, we didn't note this before, but this is a vertical stretch by a scale factor of 3. I know that because the 3 was outside of the parentheses. And what we should label this is 3 times f of x. Okay, that is what g of x is going to be. So now I have -2, 3/4. I have -1, 1.5. I have 0, 3. 1, 6. And 2, 12 would be way off the graph. Okay, and we're going to label this g of x. Okay, let's look at number 5. What we have here, negative 2 through 2. That's what I'm choosing for my x values. I have g of x equals 2 times the absolute value of x. And so what I believe we have is a parent function here of the absolute value of x. Okay, remember when we take the absolute value of anything, it's going to be positive because it is the distance from 0. That's what absolute value is. And so how do I come up with these values here? Absolute value of negative 2 is 2. Negative 1 is 1, and so on. All right, so the first thing I'm going to do is plug these, or plot these 2 points here. And by the way, before I do that, why did I leave the third column open this time? This is going to be a vertical change, and so I'm going to need new y values. I know it's a vertical change because the 2 is outside of the absolute value bars. Okay, so plotting negative 2 comma 2, negative 1 comma 1, 0 comma 0, 1, 1, and 2, 2. And all I need to do at this point is connect with a straight line. Be careful, these will continue to go at exact points. All right. And I need to make sure I have arrows here. Let's label this as f of x. And since I need new y values here, I am going to multiply the old y values by 2. And so this would be stretch vertically by a scale factor of 2. So this would be 4, 2, 0, 2, and 4. And now let's plot the negative 2 comma 4 point. Okay, you see that point's been vertically stretched, negative 1 comma 2. So that point's been vertically stretched, 0, 0 stays, 1 comma 2. This point gets vertically stretched up here, and 2 comma 4, so this point gets vertically stretched up there. And so then let's do the same thing we did with the original parent function, and make sure that we put arrowheads on the ends. Let's label this g of x. Alright, let's look at the last example here. This appears to be a parent function of the square root of x. Okay, so let's go f of x equals the square root of x. Now this is going to be a horizontal change, okay, and so I'm going to leave the column in the middle open so that I have another or a space for the new x values so that we get a side-to-side movement. How did I get these y values for the parent function? Simply plug in the x values. So this is absolute value of negative 2, negative 1, absolute value of 0, and so on. Okay, so now at this point we can go through and plot. We have, we have negative 2, 2. We have negative 1, 1, 0, 0, 1, 1, and 2, 2. And so then what we can do is connect with a smooth curve. All right, and then let's label this as f of x. Now, because the 2 is inside the parentheses, we know we have a horizontal compression. We have k equals, remember inside the parentheses, scale factor is going to be the reciprocal. So scale factor of 1/2. Okay, so let's multiply each of the x values by 1/2. So we have a negative 1, we have negative 1/2, 0, 1/2, and 1. And now let's plot these points. This is negative 1 comma 2. So negative 1 comma 2. We have negative 1/2 comma 1, 0, 0, 1/2 comma 1, and 2. 1 comma 2. And now let's simply connect with straight lines. And you can see, because it's a horizontal compression, we have compressed inward on this function. And let's simply label this as g of x. So that concludes the video for 12.3. If you have any questions, please make sure to ask them next time I see you in class.